Thank you. Today I'll be talking about my experiences with creating a serverless solution using Azure Functions. Who of y'all has some experience with Azure Functions? A couple of hands, good. AWS, Lambdas? None, good. Oh, one. Okay, two. Okay, good. Google Functions? One. Okay, cool. Well, I'm not talking about AWS and Google Functions because I don't have any experience with those. I'm only working with the Microsoft stack, so I'll be focusing on this. I guess not everyone is up to speed in what serverless is and what does it do. So I'll be doing a short introductory to what the serverless is. Because the name is a bit confusing, there are multiple threads on Twitter and hate mails and flame baits around the internet telling serverless isn't a good name because there are still servers. The thing is, you don't have to care about them anymore. This is actually the same promise, or at least I think it's the same promise we had a couple of years ago when the major cloud providers decided to throw the PaaS acronym towards us. The thing is, with PaaS, you still have to think a bit about your servers. You still have to choose which virtual machine or which size of virtual machine you want to run on, and if you want to scale and how you want to scale and stuff like that. Another thing is most PaaS offerings, which there are today, aren't fast enough. Most of the time you spin up a PaaS solution like an Azure App Service to host your website, and most of the time you want your website to be up and running 24/7 and never shut down. A nice quote from Adrian Cockcroft. He's like the Scott Guthrie of AWS, of Amazon. He states, if your PaaS service can spin up in, well, a very short amount of time, do some work and be killed, you can call your PaaS solution a serverless solution. Well, I don't know if any one of you have tried it, but most app services I've used, be it in AWS and Azure, don't spin up in a couple of milliseconds. It will take a couple of seconds, or maybe sometimes even a couple of minutes to spin up. Maybe some of you think, well, this sounds a lot like working with containers, because you can use containers to spin up really quickly, do some work and kill them. The thing is, containers are a totally different level of abstraction of logic. You can see it in the diagram over here. Of course, we have the ER solutions, which are just virtual machines and virtual networks and doing stuff you most of the time want to avoid. Then you have the container platform, which is a more scripted environment compared to the ER solution. This is where the container platform is. You need a lot of configuration, manage the virtual networks, and even if you want to share or load balance stuff. Still, containers are awesome, but I like functions as a service a bit more, because you just have to manage your own code and not where it's running and how it's running. It just, you know, it will scale, well, practically indefinitely, or at least it should. And you can just, well, do anything you want with it, as long as it's an action which is triggered or something like it. Of course, there's the PaaS solutions somewhere in the middle, because, well, like I said, it's somewhere in the middle. You have to care about servers a bit. Now there is one thing which the Azure Function team has released a couple of weeks ago, which is the Azure Function runtime, which makes it possible to run your Azure Functions locally on premise, but also in a container. I think there's even an Azure Function container nowadays, which you can use to run Azure Functions in your Kubernetes environment if you want. Well, of course, this isn't very serverless, because you have to spin up your Kubernetes cluster, which is running on servers, and you have to manage them. So that's a short introductory on functions, or Azure Functions and serverless. I can do a complete talk on the major differences and why it's awesome, but I won't. So I will explain a bit on the real life scenario I came up with. A couple of months ago, I needed to have, or I wanted to have, some minified URLs to use in my talks, to use in my blog posts, and well, what better way to do it is to make an account on Bitly and have Bitly do all this amazing stuff for me. One other thing you get with Bitly for free is some awesome analytics with charts and graphs and stuff like that. This worked awesome. I even had some custom DNS name attached to it and was able to create custom slugs for my minified URLs, which is even better, of course. Until after, I think, a couple of weeks, maybe a month, I wanted to create a new minified URL, and they asked me to upgrade to the premium plan offering they had. Well, no problem. I like paying for software, and when it's good software, or a service, it's even better. But when I came down to the pricing page, they asked me to spend $1,000 per month for their service. I thought, well, I don't have to complain, but that's a bit much even for me. So I thought, well, can I do this myself? Because what does a URL minification service do? Well, it has a get endpoint and it has a create endpoint. You want to create a minified URL which has the minified slug and the actual full URL you want to redirect to, and the get with, well, your custom DNS name and your custom minified URL. So how hard could it be? Having two endpoints, some store somewhere. The create, of course, is a nice command, and the get is a query. Two of the two words which fit nicely in the CQRS pattern. I don't know if you all are familiar with it. A couple of heads nodding. Cool, cool. Well, with CQRS you have, like I said, commands, you have queries, and you have a way to segregate them, segregate the responsibilities of reading and writing data. How this looks in how this looks in this diagram? Well, you have a user. This user can do some writing inside its page or inside an API. It sends a command. The right side of your code will update the write data store, and this data store will persist the data very quickly because it's optimized for writing. Whenever a change occurs in this write data store, this change will be updated also in the read data store, but the main differences between these stores are the read data store is optimized for reading, and so your data will probably be saved in a denormalized state, which is awesome for reading, of course. And of course, the API side for reading will do a simple select record from database and return it to the user again, which should be really fast. The reason I'm mentioning this is because I think, at least for my solution, my Azure Function solution, this is a perfect fit because I'm doing some writing of an object, and when reading this object, I don't want to have all the data stored. I just want to get the full minified URL, or the full URL which belongs to my minified slug. So it adds a bit of complexity, and it's not very necessary because, well, reading one record from a database should be quite fast, but it's awesome to implement it like this. Then for the repository, because I want to use a totally serverless solution, I chose to use Cosmos DB, which is an awesome serverless database. It's not very cheap, or at least, well, it is very cheap, but not for what I'm using it. Someone else had the same idea of creating a URL minification service a couple of weeks ago, and he used the blob table store for this, which is actually quite cheap because you're only paying for storage, and storing a couple of strings doesn't take up a lot of gigabytes. I think he spent about 17 cents per month for a, well, rather successful minification, URL minification service. I'm spending at least $20 a month because Cosmos DB, the lowest price point is about $20. And then, of course, the invocations of my Azure Function, which cost, well, nothing because Azure Functions are rather cheap. I don't know the exact number, but it's almost free. So this is what I came up with using Azure Functions and Cosmos DB. One reason I also want to use Cosmos DB is because they now have, or at least for a couple of months already, they have the change feed, which is an awesome feature because whenever some change occurs in Cosmos DB, this change is being reflected on the change feed. You can see it as some kind of a queuing system. And you can attach an Azure function to this change feed, which means I can update a different repository which holds my read data. And what better way to, this is awesome for my CQRS pattern I want to use because I needed some way to update the read repository. For a read repository I wanted to use Redis cache because every good architecture needs a cache, of course. So that's the way I wanted to do this. Now for a non-serverless solution, first I wanted to go back a bit and thinking about how I would solve such a minification service in a non-serverless way, so like I did, well, 2 months ago, probably. Well, that's just creating a new web application, hosting a website in it, and storing data inside some kind of a repository like SQL or Cosmos, which is rather easy, just exposing a web API endpoint or 2 endpoints, as a matter of fact, and you're done. But that's not very exciting and not something I like doing in my evenings. So for the serverless solution, I've changed the design to this, having one get HTTP trigger and one post HTTP trigger. The post obviously for creating minified URL records inside my Cosmos DB, and one HTTP trigger to get and being redirected to the full URL. Rather simple, a bit too simple in my opinion, because this isn't very exciting either. This was my first minimum viable product and it just works, but it was done in like 5 minutes, so I had to do something else the rest of the evening. So what I came up with later, and using the change feed, this diagram, is having the change feed and having an Azure function being triggered by the change feed and updating my Redis cache. This is a bit more awesome because now I finally have my cache and I have used the change feed. This looks a bit better. And then I still wasn't very happy with this design because the post directly writes inside my Cosmos DB, and aside from using a cache in a perfect architecture, you also need the queue, of course. So I added a queue in the middle. So having the post doing some validation logic or something like this. Having a queue, so my backend is totally abstracted and can run asynchronous. The queue is attached to a trigger, another Azure function which is triggered by messages on the queue, or a topic to be specific, and this Azure function will write to the Cosmos DB. This looks rather complex, or at least if you're not familiar with this stuff, or if you're not running in Azure, this is quite complex. But it actually isn't very when using Azure Functions, because a lot of this stuff runs out of the box and you're still, well, not done in 5 minutes, but you can implement this in like, well, an evening if you're unlucky. The thing is, when I come up with this design, and I think still to this day, there isn't built-in functionality to write to a Redis cache yet. I don't know what the state of this is yet, as of this moment, but when I last checked out the bindings and the triggers of Azure Functions, I couldn't use Redis cache out of the box. So I scrapped this part of my design for now. There has been an announcement you can create your own custom bindings and own custom triggers for Azure Functions. So now there are a lot of bindings and triggers out of the box provided by the Azure Function team, like an HTTP trigger, like I mentioned. There's also a queue trigger, which I'm using, a Cosmos DB trigger for the for the change feed, and also there are a lot of bindings, like You could use a binding to write to a blob storage, write inside the Cosmos DB, write back to a queue, a lot of other bindings, which is, well, actually very awesome, because who likes writing a repository layer? No hands. Who likes writing file readers and file writers? No one. So me neither. So I'm actually quite happy the Azure Function teams has done this, and I can make use of their awesome attributes. And now, like I mentioned, it's also possible to create your own. So I will implement the Redis cache option later on, once I have created my own Redis cache trigger and function. And I'm betting the Azure Function team will do this in some time also, but let's see who's first. So how do these bindings and triggers work? Well, you just specify them in JSON, a function JSON to be specific. This is an example of an HTTP trigger. This HTTP trigger, well, is the type. You just have to know the name and the casing of it. You have to, for an HTTP trigger, you have to specify the route, the methods, how you want to access it, and well, some other properties which can and can't be important to mention. Authorization, I want the whole world to use my minification service, of course, so I'm setting it to anonymous. But as you can imagine, my backend Azure Functions should have some authentication on it, like an administration or a user inside it, or a function. If you specify one of those values, you have to add a bearer token or an authentication token. I don't know exactly to your requests, but it's not something I'm using at this moment. And of course, last but not least, the name of the parameter, which will hold all the information of your trigger. Well, that's about it for an HTTP trigger. Of course, there's also a binding to a Cosmos DB, which looks a bit like this. Very much the same. You still have a name and you still have a type, and some other specific values you have to specify to connect to the Cosmos DB in my case. Not very exciting. You can look this up in the very well-written Azure Function documentation on the Microsoft sites. So that's about it for using bindings and triggers. But I would advise you, something worth mentioning, of course. If you're using output bindings, like writing inside a Cosmos DB, you have to specify the out keyword. Otherwise, Azure Function runtime won't understand what to do with it, and it won't write in your Cosmos DB, for instance. Ask me how I know. I forgot the out keyword. But all in all, don't write JSON. JSON is awful, in my opinion. I always mess up the curly braces. I always mess up the indenting, and Visual Studio doesn't help much when having big JSON files. So don't do it. And if you're using Visual Studio already, you should install the Azure Function runtime, and this runtime will create these function.json files automatically for you. So now for some coding, or not, because there's still something else I want to mention, which is where will you put the code? A lot of examples, including on the documentation stage, you should just write your small function inside the CSX file, which you can edit and modify on the Azure portal. This is, of course, a very, very, very bad solution. I think Henry will talk about this later on, why changing code in production is a bad thing. But I think it's not a good thing. And also, do you want to specify all of your logic inside one function method? Or at least if you're using Visual Studio, do you want to have one run method containing all of your logic which should do one thing? Well, that's up for debate. It could if it's small enough, but if there are some more complex logic like validation logic which might be important for your company, let's say validating if a request has the correct created time or something like that, Maybe you want to hold this inside a business function, and also to minimize the code duplication. It might be better to have some kind of a business layer or some kind of business, well, let's call it a business assembly reference or something like this, some kind of a business layer. You don't have to create dozens and dozens of layers, because that's just silly. And also code duplication isn't a bad thing per se, but if you can minimize it, well, it might be a good idea. Then there's the thing of should you use your favorite libraries? I like log4net, I like Autovac, I like Automapper, and there are a lot of other libraries I like using in all of my solutions. There are a couple of solutions, I just add them. I have a default NuGet install package script, which I run in a solution, and I got everything. But should you use them with Azure Functions? Well, not per se, at least that's my opinion, because when you add your favorite libraries, it adds up in the total package size of your function app, your Azure Function assembly, which will get deployed to, well, to your function app in the cloud. And what's the bad thing about it? Being serverless, every time your function is invoked, the Azure Function tooling in Azure will deploy your function app to this, well, new server it will run on, compile it, and actually execute. As you can imagine, for those of you who have worked with IaaS and sometimes run F5 or just rebuild your website, this might take some time. So having a cold start every time and being dependent on your libraries, which do one thing really good, might add up to the milliseconds of delay you're having when running your Azure Function. So be wary about adding libraries, especially if you can do the work the library does very well by yourself. Of course, not everything can be done by yourself very well, so don't be afraid of using it, but use them with caution. And then there's, of course, testing. Should you do it? Well, of course, everyone needs 100% coverage in their solution, because that's awesome and that's what the experts are saying. Well, I'm probably not an expert, because I'm saying, well, don't write tests which are silly. Only test the stuff which matters, the business logic, some validation logic which might be important to you, some calculations which might be important to you. Yeah, test those, but why test a function of 2-3 lines which does something very simple, and if someone needs to change it in the future, he can probably understand the implications of this change, and if not, well, you can just redeploy a new version of this function if a bug is found. But having functions which is only 10 lines or something like this, well, you don't have to test it, at least it's my opinion. You don't have to test everything or have 100% coverage. Only test the stuff that matters. Still, of course, normal principles still apply. So I'm a big fan, a big believer of having the single responsibility, especially with functions. Each function should do only one thing and do it very well, like validation, like I mentioned, like writing to some Cosmos DB, for example, like retrieving data, like, well, doing a calculation. All of these things should do only one, all of the functions should only do one thing, and that's the way you can keep your Azure Functions rather small. Also, interface segregation. If you're using dependencies in your Azure Function, just work with interfaces to contracts. It's something we have been doing for, well, what is it? A couple of decades already, and it's a good practice, so why not do it? It also helps you with testing if you need to do this, and if you need to do this, and also dependency injection, useful, of course. But dependency injection, most of you probably use some kind of an IOC container, like a structure map, Autovac, Ninject, Unity, stuff like that. Do you want to use this with an Azure Function? Because, of course, you have a new library which you're dependent on, but also you have to spin up your IOC container. which will take up some compute. It might be 1 millisecond, might be 2 milliseconds, but it still adds up. So do you want to have an IOC container for your Azure Functions, which only does one thing? I think not. That's why I'm not using IOC containers anymore, or at least not when creating Azure Functions. I just do something like this. Having a default constructor, which I'm using all out throughout my functions, which is just most of the time one invocation. And having an overload of the constructor, which adds the dependency, which is only being used for testing purposes. Most of the time, I only have one implementation of this interface, in this case the iCosmos client, because if you have two implementations of an interface inside one Azure function, in my opinion you're doing it wrong, because why have, let's say, a Mongo Cosmos DB client and a Cassandra Cosmos DB client inside one Azure function? It would probably be better if you create two Azure functions, both one writing to Mongo and one writing to Cassandra, and being triggered by a different message on your queue or topic or some other variable, which makes sure either one is invoked. So that will make working with dependencies and injection a lot easier. At least that's my experience with creating this solution. So on creating the solution, let's dive into Visual Studio. So this is the solution I want to create, having an HTTP trigger for retrieving data, having an HTTP trigger for creating, posting data, having a queue which holds my incoming messages for creating minified URLs. The best thing about having this queue over topic, I can create additional subscriptions for other stuff I want to create, like maybe I want to add logging later on, maybe I want to do some governance on the created minified URLs, maybe I want to do XYZ later on. So an awesome use case for topics. And I have to create a trigger which will process the data which is coming from the queue and store it inside the Cosmos DB. As I mentioned, I won't be using the change feed and the Azure Cache because it's not supported out of the box yet, or at least the change feed is, but the Redis cache isn't. So probably if you're talking to me in a couple of months, I will have implemented this solution, but not just yet.
Awesome. So let's start with a completely empty Visual Studio. Whenever you want to create a function app, just make sure you install the latest Azure Function tooling, so you'll get this nice Azure Function template. That's all there is to it. This will create a new function app solution for you. Because it's a new template, you can choose, do you want an HTTP trigger, a queue trigger, or a timer trigger. Those are the default. You can also choose in the latest version if you want a V1 or a V2. V1 is just .NET Core, .NET Framework, V2 .NET Core, which is still in preview, and it's quite a bit slower today, maybe not tomorrow. But today it's quite a bit slower, so just choose V1 if you want to use this stuff in production. And we want to have an HTTP trigger. I'm using the storage emulator, which makes sure some data is being persisted inside the blobs. Azure Functions do need blobs because your code has to be stored somewhere. Access rights, anonymous in our case. You can change this any time you like.
This would all be JSON, generating JSON?
This is creating C# files. Because I'm using Visual Studio, this will create C# files.
Oh, I just thought because the type and anonymous and whatever, I saw that early in the JSON.
Correct. This will be built into JSON files. Let's just wait for the project to be created. You might have noticed I've mentioned function app. This will get deployed as one big function app, and a function app can contain multiple Azure functions. You should see a function app as one which contains one piece of domain logic, as it says. So in my case, I have a function app which does URL minification, or has a URL minification solution. So in this function app, I'll just create the get, the post, the queue triggered function, and of course later I'll create the Redis cache custom binding and the triggered functions for this. But as you see, let's just do some nice indenting. As you see, I have an HTTP trigger with anonymous, get and a post, and route is null by default. This is what the wizard has done. It has created a function name function1, and whenever I'll run this, I have a function1 which can be called by localhost 7071/API/function1, and I'll trigger this code. Now when I build this, rebuild. Okay, I'll just turn on all hidden files, debug. You'll see there's a folder called function1, which reflects the name of my function. And this function1 has a function.json file inside it, which contains all of the binding information necessary to run my Azure function. Also the script file and entry point. So if you decide I don't want to have my Azure function starting point, don't want to run but want start, you should just change this also to start. Oh. And then you're done, and whenever you build, this will get changed. Oh, automatically. I didn't have to change it over here, of course, because it's generated. And all of this data is being created by the Azure Function runtime because I've set the attribute over here. And that's triggering an HTTP. So I've created a demo, of course. Oh, maybe good to mention. There's also a local settings file, which will contain all of your secret information, like the app.config or the web.config. So your connection strings, your secrets, your other stuff like this will be added to this file, or you should add it. This is for local testing, of course. Yes. Whenever you deploy this, please use Visual Studio Team Services for this, of course, for the adding application settings to your Azure function. But you can change this in a portal, of course, just under the application settings link, I guess. Yes, this is for local testing. And it's called local settings now. I think it was 15 months ago. It was called upsettings.json. So there are some changes, but I think this is quite stable now. It has been called local settings.json for a year now. So I've created a demo solution, of course. This is my demo. For the sake of time, let's just go to step 3, which is the complete solution I have. And as you can see, probably can see, is I have created a get Azure function, a create Azure function, and a process Azure function. Oh, doesn't work. And a process, just to handle all of the. Just to handle the 3 HTTP triggers, or the 3 Azure functions, the functionality I wanted to have. So the get, the post, and the process. So the get looks like this, an HTTP trigger, much like this, the one we used before, or we saw before. As I mentioned, I have a slug, this is the route, so it will be /API/ my minified URL. I want this slug to be added as a string to my code. You could also have a complex object. Complex object over here. If you have multiple properties which you want to combine inside one complex object, which is strange in a get scenario because you have a query string and doing complex objects inside a query string could be hard. So just don't. See, okay. And as I mentioned, my get method wants to read data from Cosmos DB, and in my first attempts I created my own iCosmos DB client and a Cosmos DB client which did some reading inside Cosmos DB. But a couple of weeks ago I discovered the document DB attribute and the SQL query parameter it has, so you can just do a select star from my database where the minified slug is slug. So whenever you run or trigger this function, the minified URL enumeration will contain all records inside Cosmos DB which match this criteria, which is awesome, of course, because now I can just delete the Cosmos DB client. I have proof. Over here, it's still, this is my production system. So I have the Cosmos client, and in the get, I'm still, I have a handler which does, of course, the dependency injection of the Cosmos DB client. Terrible, terrible, but because of the Azure Function team, I can just make it simpler. So entering the function, if there aren't any minified URLs, not found. If there are, get minified URL, what does this do? Oh, it takes the last. I have some error in persisting my data, so anytime I want to overwrite my minified URL, I'm creating a new record inside Cosmos, so I have to change this later on. So, but for now I'm just taking the last and create a warning, so I know I still have to fix this. Not very exciting, and when I'm done, I'm just returning an HTTP response with a redirect, of course. So this is my code isn't very interesting. What's most interesting is the HTTP trigger and the document DB binding, which make all the magic happen. Of course, you have to specify which database and which partition you want to use and the connection string, but that's all very straightforward. All of this stuff is added inside the local settings JSON over here. Of course, we have the create, and if you remember, the create Azure function also is an HTTP trigger, which writes back to the service bus. So let's fix the indenting over here. We still have the anonymous with the post and the route create, and I'm posting a message to this request. I'm posting a request to this, and whenever there's a request, I deserialize it to an object I want, validate the data if it's valid. If not, I respond to bad request, and if it is valid, what I'm doing here, adding some data, like I mentioned, the created date. So not very exciting. You could just skip this if you want to, and create a response. My minified URL will be created with this endpoint. And if I'm lucky, if I've specified this correctly with the correct connection string and the correct, I guess this is the subscription, the topic I want to, the topic name, yes, and the connection name, and it will be written to the service bus topic. Fairly straightforward. I didn't have to do anything for this myself, just create some validation logic. And that's the creation. In order to invoke this man, I'm just using Postman because I don't need a UI for this. There it is. Not. Move. There it is. So create a minified link. I'm posting to the create endpoint. This is the JSON I'm sending, so the minified slug, .NET Meetup Amsterdam, the full URL, .NET Amsterdam. And whenever I send this to my Azure function, it should persist it, or it should create a new record on the service bus. And whenever a new record is added to the service bus, I have this process, Azure function, which has a service bus trigger. As you can see, this is a service bus trigger, and this is a service bus binding. This is stuff you have to know when you're using Azure Functions. I haven't thought of this, I haven't made this up myself. And the documentation is quite clear. So service bus trigger, the queue topic name, the subscription. Yes, you need to manage access rights. I don't know why, because I thought listen would be good enough, but having a listen connection doesn't work, so please use the manage. And of course the connection string to your service bus. You'll get a minified URL. I know it's a minified URL object. If it's not, you'll get an exception thrown in your logging. So I know it's a minified URL because I have bound it over here. And over here you can see I'm using a binder instead of using the Cosmos DB binding again, like I did in the get. Over here you can see I've used the document DB binding in order to add data to Cosmos. I'm not doing this in the process because I don't want to specify secrets inside my local settings or inside my application settings. I want to specify secrets in key vault because it's meant to hold secrets. You can do this, but only for bindings. It doesn't work for triggers. So there's still an issue on GitHub Open, where people are asking, well, please add this binding, add this key vault support also for triggers, so I don't have to specify this connection string anymore over here. But at the moment it's still under review, or at least not implemented. So when using the output binding, I have created a small helper method to do this. Over here I'm creating an iasync collector with minified URLs. So if you want to add data to Cosmos DB, or I think it's also for other repositories you want to write to, like, well, let's say a blob storage also is a repository. You also need the async collectors, or the async collectors. So what you do over here is having a binder. The binder needs to you need to add a document DB attribute to this, which is actually the same as the one over here. It's just so what you're doing over here in the get function is actually exactly the same as doing over here, only just I'm using Azure Key Vault data for binding my data over here. So I've created a helper class secret, which does the actual Key Vault retrieval of settings. If you think of using Key Vault in your own production system, please make sure this Key Vault client is created as a singleton, or something which looks like a singleton, because the Key Vault client and any other client to some other system is quite expensive to create. And if it is thread safe, you should share it across your instances, because even though serverless doesn't, or Azure Functions is serverless, doesn't mean every invocation of your Azure function is hosted on a different server. A lot of the times your Azure function invocation, your Azure function instances are being reused, and if not, it's probably deployed on the same server, or it might be deployed on the same server. And if you have this key vault client or any other client set up as a singleton, you don't waste CPU cycles to create all of this stuff again. So that's just a heads up. So that's the processing, and as you can see, I'm not doing anything interesting over here. I'm creating the binding. I could also have used the same binding as in the get method, but I've used something more fancy over here. Creating the new minified URL, which is just doing some mapping to a new object. Not very interesting, but well, necessary, or at least I wanted to do this, and adding it to my output binding, which I've created over here. That's about it for creating an Azure Function solution. So the most important thing you have to remember is just use bindings and triggers, and don't do stuff like this yourself, because bindings and triggers are quite powerful.
Because my Azure Function is running now, that's okay. Just send it to the localhost endpoint API/create with the body JSON. Send. With a bit of luck, it will tell me it has been created with the following URL. I think I'm too late. It's probably picked up already from the topic. Otherwise, we can see it over here. No, it's already gone. Sorry. But otherwise, you could see over here the message which has been placed on site, the subscription. That is already being picked up by the process Azure Function, which should be mentioned over here somewhere. Processing. Executing the process. So it's gone and it's being created. Now I can use Postman to create or to retrieve the minified URL contents. Just get a localhost API endpoint. Send. And I should get some HTML over here. This actually takes up a bit of time. That's because I had something selected, and whenever that happens inside your console window, the process stops. Awesome. But whenever you move the selection from your console window, you'll see you'll retrieve the data. And it actually works. I have the link over here. It actually works in browsers also. So when using the link, I'm navigated or redirected to the Move Up with Azure event on the for.net website. Awesome, everything works. Aside from the fact that I'm still having the API in the middle. This is something I don't want, because I've just created a minified URL service, and now I'm stuck with this 4 characters API / which are rather obsolete. So there's something else you can do, and which the function team has provided, and I think it's whoa, let's go back in time. I think it's global available nowadays, which is proxies. Proxies, I think, like I mentioned, I think it's global available now, but I'm not sure. It was in preview, and it's very nice, because with proxies, you're able to strip away the API. Like I mentioned, you don't want this, but you want the friendly HTTPS, blah, 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 / minified URL, sparing 4 characters, which is much better. And actually, I'm not very satisfied with this also, because as you see, I still have the m.jdv.ly / something. That's because Azure Functions doesn't support A records for your DNS yet, which makes sense, of course, because A records point to an IP address, and if your code isn't running on a server, or not a dedicated server, or handled via some kind of a load balancer, you don't have an IP address. They're working on this to support A records for your DNS and your functions. I don't envy the people who are creating this, because gather it's rather difficult, but they're working on it. So maybe in the future I will be able to strip away the M and have an actual working proper minified URL service. So how does this work? Well, again with a JSON file, and this looks a bit like this. You have to specify a proxy block. In the proxy is a JSON file, just add it to your project. Specify the name of your proxy. I've named mine the get minified redirect. The match condition, well, in my case, I only want the get endpoint to be handled for this with a specific route. So, like I mentioned, / minified URL, which is the slug, and specify where it will be proxied to. In my case, it's the /API / slug. You can also point to a different Azure function. You can point to google.com. You can point to anywhere you like. It doesn't matter much. The runtime will handle it. So that's about it for my talk. If you have any questions or want to contact me, feel free to ask them now or later on. Here are my contact details. Just mail them to my Fortinet account and I'll respond rather quickly when I'm not sleeping. The full source code can be found on GitHub, and some more details on how I implemented this or some other stuff I will find in the future will be posted on my blog, Jan V.